right, good afternoon, Algebra 1, periods 1, 6, and 7. This is Mays coming at you from 308. It's the 1st of June, semester test week. So, in preparation for your semester test, I figured I'd give you a little help. Now, the very first page where it says to graph those three lines and then tell me the area of the resultant triangle, wow, I'm just going to let you do that one. If you're having trouble graphing three lines on the graph provided and telling me the area of the resultant shape, then we should probably see you next year in Algebra 1. Okay, but problem 3 and 4, where I give you two parabolas, I just show you two parabolas, I give you two equations, and then I say, find the vertexes and tell me the equation of the line that goes through them. And then problem number 4 says, how far apart are the two parabolas? All right, so let's take the first part. I'm going to give you an example that's very, very similar to what you have. In fact, this one's even uglier than one you have. So if you can get through this one, problem 3 and 4 will be a breeze. All right. Semester test. Semester 2, Algebra 1. This is problems 3 and 4. I give you two parabolas. Okay, in this case, we're given f of x is equal to negative x squared plus 12x minus 32. And f of x is equal to 1/4 x squared plus 5 halves x minus 11 fourths. Isn't that an absolute ugly looking thing? Yeah, all right. So then the directions say find the equation of the line in slope-intercept form that goes through the vertexes. All right, so what do you got to do? You got to find the vertexes. How do you find the vertex of a parabola? Well, first, axis of symmetry, people. Axis of symmetry. X is equal to negative b over 2a. The vertex is on the axis of symmetry. That's the x value of the vertex. So, let's do the hard one first. So f of x is equal to 1/4 x squared plus 5 half x minus 11 quarters. So a is equal to 1/4 and b is equal to 5 halves. So x is equal to negative b, negative 5 halves, all over 2 times a fourth. Well, negative 5 halves over a half, invert and multiply, and the x value of the vertex is negative 5. That's the axis of symmetry. X is equal to negative 5. That is also the x value of your vertex. Okay? Now, stick the negative 5 in for x. Now remember, function notation, I can ask the question, when x is 5, what's the output? The input's negative 5, what's the output? So if I do all that fancy stuff, look at that. Isn't that beautiful? I get that. Common denominator, people, common denominator. I change it all to fourths. And y is equal to 9. Okay? Y is equal to 9. So when x is negative 5, y is negative 9. So that's your first vertex. Okay? Now, let's find the second vertex. Now this one's a lot nicer, isn't it? A is negative 1 and b is 12. Negative 12 over negative 2. The axis of symmetry is x is equal to 6. So, the x value of the vertex is 6. So if you put a 6 into the function, what do you get out? Well, f of 6. Put the 6 in. Look at this, look at this, look at this, look at this, look at this. And y is equal to 4. Okay? See how we did that? The thing that's going to mess you up is that negative sign out front. Square the 6, and then go opposite. Okay? All right. So now you know that vertex. 6 comma negative 4, and the other one, negative 5, negative 9. All right, so those become the 2 points I want to find the equation of the line that goes through. Those 2 points. All right? So the first thing you always must do is find the slope. Remember, slope is the change in y over the change in x. y2 minus y1 over x2 minus x1. Now, I labeled my data. If I label my data, it's really hard to mess it up. Okay? Negative 9 minus 4, negative 5 minus 6, and the slope of that line is an awe-inspiring 13 over 11. Isn't that pretty? Yeah, I know, I missed a little bit, but that's okay. You can still do this. So, y is equal to mx plus b. Now, I chose to use that form, solve for b, and then put it back together, okay? I have a point. I have a slope. I need the y-axis intercept. I need the b. So I chose 4 comma 6. Y is 4. X is 6. I plugged them in. and I solved it for b. And b is equal to, whoop, that should be a negative. That's a negative 34/11ths. All right, the correction team has to come onto the field. And the correction team corrects it. There, that's right. Because 44 minus 78 is definitely negative. Negative 34/11ths, okay? We got to fix it here too. There we go. So I build my equation back up, and I get y is equal to 13/11ths, x minus 34/11ths, okay? So there's the equation of the line that goes through those two vertexes. Your equation is a lot prettier than that, all right? Now, question number 4, it says, how far apart are the parabolas? Well, you can think of this on the x-axis, okay, on the x-axis. So I drew an x-axis, and I put 4 points on the x-axis because I'm assuming that the parabolas cross the x-axis. Well, of course they do. I can look at the vertexes and tell you that, okay? I got one below and it opens up. I got one above and it opens down, okay? So all you just need to find the 4 points of intersection on the x-axis. How do you find the points of intersection on the x-axis? You set it equal to 0 and you solve it. So the first one, let's knock this one out first. So 0 is equal to 1/4 x squared plus 5/2 x minus 11/4. I don't like the fractions. I'm going to clear the fractions by multiplying everything by 4. Now I got x squared plus 10x minus 11 is equal to 0. I can factor that. I can solve each factor by setting each of them equal to 0, and x is equal to negative 11, and x is equal to positive 1. So I put negative 11 and positive 1. That's where that parabola crosses the x-axis, okay? Now the second one, I got negative x squared plus 12x minus 32 is equal to 0. I don't like the lead coefficient squared being negative, so I just multiply it all by negative 1. And that factors beautifully, x minus 8, x minus 4. Solve each factor, setting it equal to 0, and x is equal to 8, and x is equal to 4. So I put those 2 points on my little x-axis. Now, how far apart are they? Well, 1 to 4, 3 units. On the x-axis, these two parabolas are 3 units apart, okay? All right. That's how you do that problem. So there's an example of how to do that. I'll post some more up here for you guys, but that should get you through problems 1, 2, 3, and 4. You only have 11, and the other ones aren't too bad, okay? Anyway, distance formula. Look that up, okay? Let me put it up here real quick for you. D is equal to the square root. You got x2 minus x1, y2 minus y1. And you turn it around. All right, that's your distance formula. You kind of need to have that one too, okay? All right, you'll need that one for the last one. You get that funny rectangle sitting on that grid. Okay, more to follow. But until the next video, May's out.